Okay, I would like to talk to you about the logarithmic function. You've heard a lot about it in the past with the Richter scale. It's being applied even with some of the graphs you have with coronavirus, the COVID-19. Some of the data is represented in log graphs, and yeah, so it's used widely and it's very practical within its application. Okay, so first of all, let's define what it is. Okay, as previously mentioned to you, the log graph is the inverse of the exponential graph, and we'll get to that a little bit later. But for now, today, I'm just going to introduce the 4 log laws to you and how we will apply them. So if, by definition, if we have an exponential function y equals a to the power of x, then x is equal to log base number a y. Okay, this y is not an exponent to a. Keep that in mind. This is something completely else. This is a base number of the log function, and that is why it's a variable. Okay, so it will be clear in our examples how it works. So our very first log law looks like this. If you have log with a base, let's make it a, and you have m times n, it's equal to log base a m plus log base a n. Okay, so this is our first log law. Now let's look at the second one. The second one looks like this. Again, would be very similar to this one. Log base a of m divided by n. It will be equal to log base a m minus log base a n. You will notice there's similarities with the exponential laws. If you want to see how to prove these laws, you're more than welcome to go to your textbook. It's on page 61 and 62. But the proofs are not examinable. You don't have to know how to prove it, but you have to know how to apply these laws. So then this is the first 2 laws. The third law looks like this. If you have log base a m to the power of n, this exponent to m is now an exponent to m. It can be written in the front as n times log base a m. And again, if you want to understand this in a deeper way, go look at the proof. It's really actually fascinating to look at these different log laws. And then the fourth and final one looks like this. Log base a m can be rewritten as follows. Log with another base m divided by log with another base, the same, these two have to be the same, a. And these laws again can be applied interchangeably. It's an equal to sign, so it goes into both directions. And so we are going to use this a lot in our calculation. So these are the 4 log laws. So now let's look at a few examples. So number 1 looks like this. Log base 3 of 3 times 27. So we are going to apply two different laws in this case. First of all, we can split these. Now there's a few ways of doing this. You can either split this up and say this is log base 3 plus log base 327, or you can go further and just multiply these two with each other as well. It really doesn't matter in this case. Let's do both. So the first way would be, let's multiply. So 3 times 27 is 81. And we understand that 81 is 3 to the power of 4. So this can be rewritten as log base 3 to the power of 4. And then we can apply the log law by taking the 4 to the front. So this is 4 log 3 base 3. And this is something that I did not mention to you previously, but I want to write it down, that if you have a number and the base and the number is the same, log base a, that becomes 1. That value is 1. And you'll see that a lot with our application as well. So keep that in mind. Keep that in mind. This correlates with the exponential law, where everything to the power of 0 is equal to 1. But again, that will make more sense if we do the proofs. Okay, so this then gives us a final answer of 4 times 1, which is just equal to 4. Let's do the other one, just for the fun of it. So that you can see it works out perfectly. So we have log base 3 plus log base 327. Log 3 is already equal to 1. Then you have log 3 to the power of 3, because 3 to the power of 3 is equal to 27. That 3 can go to the front. And then we'll have 1 plus 3 log base 3 times 3 is just 1 plus 3 is equal to 4. And yeah, so even if we do it in another way, it still works out perfectly fine. Okay, let's move over to example 2. So let's simplify this by using the log laws. You will see we've got a multiplication and a division. So technically, we can write this down as follows. Log base b k times d minus log base b m. We applied the divide first, and this one, the first term, we can apply the first log law by writing it down as an addition. And to remember the last term, please. And that's it. That's how we simplify this one. Let's move over to number 3. Here we go. Log of 10,000 divided by 100. Now, please understand and remember this. If no base is indicated, like on your calculator, there's just a log button. If no base is indicated, that means that this base is 10. So you can literally understand it in this way. So if no base is indicated, the base is 10. Okay, let's simplify. 10,000 divided by 100 becomes 100. So this is log 100. Remember now the base is 10. So we would like to work towards 10 to the power of if we can. So we know that 100 is 10 squared. We can take the 2 to the front. So this becomes 2 times log 10. Now if you use a calculator just quickly and say log 10 equals, you'll see that it becomes 1 because the base is now the same as the number. So this becomes 1, so the final answer is just 2. And that's it. Good luck with your calculations.